Hello everyone. So I will present you the challenge one. So I'm managing the challenge with Raya. Before we were working with Benoit, Gabriel, but he take other positions and other responsibilities. So I'm now managing the challenge with Raya. So I will just briefly reintroduce what the challenge is and what are the main objectives of the challenge. So here the idea is really to work on the land-based mitigation measures with the idea of those land-based mitigation measures. They have to be multi-criteria and multi-objective. So it's not only about storing carbon in the biomass or in the soil, it's also reducing other greenhouse gases emissions, and also they have to be attractive from an economical point of view. So the farmers or the landowners who implement those strategies, they also have to have at least the same amount of money, the same salary, etc. So that's the main objectives of the challenge. And it has been divided so far in 3 research lines. So the first one was like a review and a design of the land-based mitigation measurements, multi-criteria assessments of those land-based measurements, and then try to see how they can contribute to the nationally determined contribution of the Paris Agreement. So we also had, so not only organizing the research, but also we tried to organize workshops. So for the 6 years that Sealant started, we organized 3 workshops. First one was organized like a fully presential workshop before COVID. It was organized in Paris. It leads to a publication, a joint publication 2 years ago. Then we had a full online workshop on the biophysical and biogeochemical effects of land-based mitigation measurements. And then, as Philippe mentioned, we organized hybrid workshop in Paris with Julia Lenoy, and the publication in the joint publication is online for a few months now. So also in the challenge ones, so in Sealant in general, we have been part of a special issue in Frontiers, and we have been guest editor of. So there was an action mainly led by one person, but with others, we have been guest editors for this special issue. So I will present you some results that are not yet published. This is so or they are in review or they are like close to be submitted. So I thought it was maybe more interesting to show non-published results than already published results. So first, this is something. It's a work that is have been partially led by Benoit, Gabriel, and myself. And it's after the internship by Celia with the idea of how is erosion really a carbon sink or a carbon source. So the idea behind that is that from an agronomical point of view, erosion is generally seen as draws because you're losing fertility, you're losing soil. But from a climate point of view, you put soil in sediments, and so this organic matter, which is burning the sediment, is decompose much more slowly, and so the greenhouse emission due to microbial activity is reduced. But the idea is that generally, if you're losing fertility, if you want to have the same exact yield in the soil that are facing erosion, you have to compensate for this loss of fertility by adding mineral fertilizer. So the idea that we had with Benoit was maybe we can combine an erosion model that was developed by Victoria Nepal and life cycle analysis to try to have a more, let's say, integrated greenhouse gas assessment of erosion. And we did that for over the Ebro Basin in Spain. So we had different scenarios. I won't enter too much into the details, but let's say that in Spain, at least in the Ebro Basin region, there is some data who are suggesting that when you protect the soil against erosion, the increase in the yields is not so high comparatively to other regions in the world. So we choose two erosion, one which is really based on observation over the specific region, and another which is an average of a global study that was done by Yansu, who was also PhD student of Sealand and then postdoc for Sealand, who did the same analysis but at global scales. And as I was saying, basically the loss of organic matter, which is predicted by the erosion model, are compensated by input of mineral nitrogen and mineral phosphorus. And that's what we got at the end. So this is the results of for the GHG emission from the life cycle analysis. And what we can see is that indeed the greenhouse gas balance of the two systems in our study and in our condition are roughly similar, even though the erosion system seems to emit a bit more greenhouse gases. But the effects of assuming that erosion leads to burial of organic matter, which is stored for at longer time scales, is maybe you maybe overestimate the effect of erosion on climate if you do not consider that you have to compensate for the loss of fertility. So this paper has been reviewed once already. We just resubmit the revised version, and hopefully it will be accepted in the coming weeks. So there is another study that I want to show you. It's a study that is coming from the PhD of Elisa Bruni. Elisa defended the paper a few years ago, but as you know, most of the time the publication of the PhD are coming afterwards. And so this is so the PhD of Elisa, the aim of the PhD of Elisa was to try to estimate how much carbon inputs are needed to reach the 4 per meter target in the soil. So the idea is, okay, we have this 4 per meter target, but it's difficult to reach the target without increasing the input. And by using simple models, she forced the models to reach the 4 per meter target, and then she see how much carbon was needed in that case. She did it at different size scales compared to observation, and the method was relatively performant. And then we wanted, in collaboration with the GRC and with Emmanuel Ligato, we wanted to see how would be the impact, how much carbon would be needed at the European scale to reach the 4 per meter. And the idea that Elisa had was that when she parameterized the model for each different site, she realized that actually the range of the parameter for the model she was using are very different depending on the sites. So if you use one set of parameters for all Europe, you probably miss a lot of the spatial viability of the system. So this is more some kind of a proof of concept than something which is very robust, because she did not have so much sites to make robust prediction of the parameter. But the idea was to see how, using the sites she had in her observation data sets, could we predict using simple statistical models the value of different parameters of the model based on, let's say, like classical boundary condition that you may have, like precipitation, temperature, texture, etc., etc. So that's what she said here, and you can see that for the parameters she chose, the prediction of the linear model was kind of okay, even though we don't have so much data. And what she said is that she tried to see how much carbon would be needed in different climate scenarios to reach the 4 per meter target. So on the left side, you have the NPP increase that is predicted by the EasyMIP models. So it's an ensemble of land surface models. So just because of CO2 increase, because of climate change, how much the NPP will increase. And then for the different climate scenarios, so the RCP 2.6 and 6.0. And here, this is what she estimates to be needed to reach the 4 per mil target. So obviously, you have a huge range of, so the spread is very large, but the main message to that is that if we want to reach the 4 per mil target, or if we want to increase soil carbon in the soil, even though without reaching the 4 per mil target, the increase that we expect from NPP just due to CO2 increase is not necessary, is not sufficient, sorry. You really need to have an active land management, including cover crops, including agroforestry or a number of different actions. So now, what is the future of the challenge one? So there are still some PhD students directly funded by the challenge one. There is also PhD students which are half funded, as Philippe explained, on topics which are related to challenge one. So we are participating and collaborating with some of them. And also we have two cross-cutting projects, as Philippe explained. So there is one about how land-based mitigation measures can affect both the biogeochemical aspects of the climate system and the biophysical aspects. So we just hired, so one of the hiring process is ongoing, so it will start soon. And there is another one. So I'm taking the opportunity to add on the position which is open. So it's about integrating those land-based mitigation measures for Europe and see what are the impact on the food security. So this, if you're interested or know someone interested, you can contact Raia, of course, me and Francesco. So we'll be also co-supervising this CCP. And I think that was my last slide. So yeah, thank you for your attention, and I'm happy to answer questions.